Hi everyone. I hope this is live. Let me just check this once. Yes, am I audible? Am I visible? So is there any issue as such? Okay, so let's get started with the mind map on excretory system. So we'll have a look at this excretory system, so which is basically, in brief, we'll have a look at this complete chapter. Okay, so this mind map is going to help you in preparation, like you have a very less time and you want to prepare well, so you can just have a look at this mind map, so which will give you ideology if you have already studied. So yes, before I start, let me introduce myself. I'm Vani Kari, biology educator at Unacademy. I'm an engineer with bachelor's and master's degree in biotechnology and a B.Ed degree. Also a founder of a startup where I grow microgreens by vertical farming technology. So this is the mind map, and the mind map is taken from Oswald ICSE Mind Maps, the biology class 10 book. Okay. So this is available in stores. You can also have this reference, or if you want this PDF, I can send the PDF of this excretory system, that is mind map. So same PDF, I can send it on my Telegram. So all you need to do is download the Unacademy Learners app. So you can also follow me on the community, or otherwise using the Telegram. So you can just search Vani Kari ICSE Class 9 and 10 Biology. So I can send this particular PDF over there. Okay. Hi Padmanabhan. Good evening. Okay, so let's have a look at this. So this is with respect to excretory system, only this part which is zoomed here. So you can have a look at this. What exactly is the excretion, and the definition related to the excretion is mentioned, and also about the osmoregulation and what are the different substances that are there. So here the excretion, when we mention, so there are different excretory product that are to be removed. So here it is the process of removal of chemical waste from the body. So what exactly is that chemical waste? So it is a nitrogenous waste, right? So what are the nitrogenous waste that are formed in human body, or in general any nitrogenous waste? Can you name few nitrogenous waste, any of you? Urea, yes, and other than that, so there is ammonia as well. Okay, so then you can also find there is, one second, just a second, yeah, and also there is a uric acid. So these three are the nitrogenous waste which are produced, and we need to get rid of these nitrogenous waste. So if they are stored in the body, so it can cause a tissue damage, and that's the reason. So we need to get rid of this, and that is by a excretory system present in our body. So that is the one which is helping in removal of these chemical waste from body. So now here, what are the different excretory substances that are there? So it is carbon dioxide, okay, and how exactly carbon dioxide removal occurs? So that is through the expiration. So exhalation is done. So along with the exhalation, you can also feel like, you can hold your hand before your mouth or like nose, and when you exhale, so you can feel some moisture content also. Okay, so that is mainly because along with this carbon dioxide removal, so there is a water vapor also that is lost. So the cellular respiration equation, so that is glucose is going to get oxidized. Okay, so upon oxidation of this glucose, so there is carbon dioxide produced, water produced, and there is energy produced. So this carbon dioxide, and along with this the water vapor formation occurs, and this also is removed. through the respiratory system. So then there is nitrogenous metabolic waste. So what all nitrogenous metabolic wastes are there? So it is mainly the urea, uric acid as well as ammonia. So excess salts which you have consumed or the vitamin which is there. So all this will be excreted out, and along with that, so there is a water. So water is removed out. So that is through the urine itself, or we can also mention it is mainly in the form of water vapor through the respiratory system as well. So then the bile pigments are removed. Water, so that is respiratory product. So all these removal can be seen, and the maintenance of this water mineral balance is done in the body, so that we call as osmoregulation. Okay, so osmoregulation, when we mention, so maintaining this water balance as well as salt balance, that is nothing but the mineral balance is done, so that is called a osmoregulation. So here the urine, okay, so urine with respect to, you can see the physical properties are mentioned, and what are the constituents, the regulation and the abdominal constituents. So all these are mentioned. Okay, so like abnormally, let's say urea. Okay, so urine production is there, but in certain cases along with the urine you can find a blood content also. So it could be because of the urinary tract infection or certain hormonal variation where you can find. So any abnormal condition which you can find associated with the urine, so that will lead to a diagnosis of a particular disease. Okay, so here with respect to the one which is given, so you can have a look at the excretory substances which are shown here. So through the lung the carbon dioxide is removed as an expired air. The mineral salts, the nitrogenous waste, mainly the urea, creatinine as well as uric acid, so these can be removed through the kidney as well as through the skin. So skin mainly through the sweat. Okay, so skin anyway we do not consider this as excretory organ. One second, yeah, so we do not consider this as excretory organ. So since basically the skin does produce the sweat, that is through the sweat gland, and a slight amount of urea removal does occur, and that's the reason, so you know, some of the books will consider it as an excretory organ itself, but specifically the sweat production does not occur, that is to get rid of urea. So it is just to cool down the body, the sweat production occurs. So as a constituent of sweat, through sweat contains only small quantity of this nitrogenous waste. So that is only in traces you can find. So then other than that, the water through the kidney, through the skin as well as through the lung. So excess water as the constituent of urine. So water lost as the main constituent of sweat. So this is through the skin, and in case of lungs it is the water vapor that is lost in the expired air. So then you can find bile pigments, so that is from hemoglobin breakdown. So this is in the liver. Okay, one second. So there is, yeah, so liver, you know, is going to form a bile pigment, so that is by breakdown of the hemoglobin from the RBC. So when the breakdown of hemoglobin occurs, so there is a bile juice which is formed, which is having a pigment like bilirubin and biliverdin. So through the intestine, so that is why a bile juice poured into the duodenum. So there is a excretory material which will be done. So moving on to the excretory organs, so there are different excretory organs that you can find. So one is with respect to sweat gland, even though it is not completely considered a excretory part itself. Okay, so it does remove a trace quantity of urea, and that's the reason it is included under excretory organ, or otherwise the sweat gland is doing a function of cooling down your body. So it is not to get rid of the urea, it is basically to cool down the body while the water is being collected from different cells, that is surrounding cells. So there is some amount of urea that will be dragged into it, and that's the reason it removes only a trace quantity. And other than that, the lungs, you know, the kidney, so there is We'll study about the structure of kidney. I'll just draw it and explain. So there is Bowman's capsule and function is mentioned here. So kidney is having enormous number of minute tubule which we call a nephron, and that nephron is arranged in the cortex region as well as the medulla region. Okay. So then there is a production of urine that happens. So there is ultrafiltration, reabsorption, and there is tubular secretion. So all these are the parts where the urine production. So these are the processes. So associated with these processes, only after completion of this there is a urine formation which you can see. So let's have a look at the structure of kidney. So now this is the kidney. Okay. So kidney, the bean shaped structure, which is again having two more coverings. So whenever you are drawing a kidney, so just make sure that you draw two coverings for this. So one being the capsule as such. Okay. Then there is a cortex region. So this particular region, so let me just use this one. So let's say this is the cortex region, and in the center, so this part if we consider, so this is going to be a medulla region. Okay, 1 second. Yeah, so this one is actually the medulla region. Okay, so this is now the cortex part and this one is the medulla part. Okay, so here let me just highlight this part. This is, okay, 1 second. Yeah, so this is now the yellow one what you see here. So this is the cortex region. Okay, so cortex region where you can find association of the nephron. So nephron is located in this particular region. Okay, and other than that you can also find, so there is a particular region, so that is the medulla region. So now the yellow one what I am drawing, so this is exactly the cortex region where you can see the Bowman's capsule, PCT, DCT are all situated here. So then comes this medulla region. So let me just color the medulla region in different ones so that you can distinction. So now this is distinguished between these two. So now this part what you find, so this is basically the medulla region part. Okay, so this part what you find here, so this is medulla region. Okay, and in medulla region you will find the Henle's loop, then also there is collecting duct situated. Okay, so this is the overall structure. So now with respect to this, let me just draw the pyramids. 1 second. So now these are the pyramids over here. Okay, so these pyramids are nothing but the conical pyramids, and these conical pyramids are basically having a striations as such. So this striations what you find, so this is made up of the structure called as Henle's loop as well as the collecting duct. So this is going to be a collecting duct over here, and here you can see a dotted appearance. So this dot appearance, what is that? So this is mainly because of the Bowman's capsule, the PCT and DCT are found here in the cortex region, and then this one gives the dotted appearance. Okay, so let's have a look at this. So this is completely going to be having a dotted appearance itself. Okay, yes. So now there are apices. Okay, so there is major groove, minor groove, where there is a pelvic region formation occurs. So associated with this you can find, so there is the pelvis. Okay, so this one is the pelvis region. Okay, and here this junction what you find where this is joining, so this we can consider as the hilum, and this one is ureter. Okay, and this one is conical pyramid. All right, and other than that, so you can find there is the cortex region. So this one is cortex region, and this blue one which is mentioned, so this is the medulla region. So there is cortex and medulla region. So this is the capsule. Okay, So this is how it is going to continue, where this region, the cortex region, will have PCT, DCT as well as Bowman's capsule, but the medulla region, the conical pyramid, will have a loop of Henle. Okay, so let's have a look at this. So this is a part of renal tubule, so you can find glomerulus. Okay, so glomerulus over here, if I have to draw this, so let me just draw. So this one is Bowman's capsule. Okay, so this is now Bowman's capsule. So the Bowman's capsule is having a structure like this. So this is Bowman's capsule. So let me just label this. So this one we call Bowman's capsule, and Bowman's capsule moves down. So there is a formation of PCT. Okay, so this is PCT. So this will continue below. So this is Henle's loop. Okay, so then you can find DCT as well, and there is a collecting duct. Okay, so this one is collecting duct. So now with respect to this, so there are structures. So there are arterioles which are running. So there is a afferent arteriole which is dividing further, and there is a efferent arteriole. Okay, so this is afferent arteriole. So there are capillary formation. So this one we call a glomerulus. Okay, so this one is glomerulus. Okay, and both of them together, so this is going to form the Malpighian capsule. So this one is going to form the Malpighian capsule. So this part is PCT, okay, and this one is DCT, the distal convoluted tubule, and the proximal convoluted tubule. So this is Henle's loop, and this one is collecting duct. Okay, so here the glomerulus is meant for ultrafiltration process. The Bowman's capsule, when we mentioned, so this is receiving the glomerular filtrate, and proximal convolution tubule, where most of the water, so once the filtration of blood is done, so this glomerular filtrate which is entering the Bowman's capsule will have water content. It will have glucose and sodium and chloride ions as well, so which are actually needed by the body. So reabsorption of most of this is gonna be seen. Okay, so reabsorbs most water and much of glucose and sodium and chloride ions. And with respect to loop of Henle, so some absorption of water and sodium ions is done. Okay, so that means you can see absorption of water, so water absorption is done, and sodium also gets absorbed, and there is a distal convoluted tubule. So reabsorption of remaining chlorides and some water, and also walls secrete potassium and foreign chemicals such as penicillin. So this is basically, in case of DCT, that is distal convoluted tubule, is meant mainly for tubular secretion. So let's say there is a urine that is being formed. Okay, so while the urine is being formed, like glomerular filtrate, so there is reabsorption process occurring. Okay, so that is selective reabsorption process is occurring. Now, like any excess amount of drugs, so let's say you are on a particular medicine, so any excess amount of these drugs are there, so these are secreted by the DCT into a forming urine, and only after tubular secretion we can call this particular urine or the glomerular filtrate a urine. So not until then. That is because these three processes have to complete: the ultrafiltration, the reabsorption, and tubular secretion process have to complete. Any doubt till this part? Okay. All right. So this one, just a second. Yeah. So now the coloration with respect to urine and like certain physical properties. So the urine which is formed after all these processes, that is ultrafiltration. So under a higher hydrostatic pressure, the blood is getting filtered and there is a formation of urine that you can see. Okay. So this urine, so there is reabsorption process also and tubular secretions. Only after that we can call it a urine. So once the urine is formed, so what exactly will be the physical property of this urine? So this will have about yellow coloration will be there, and 1 to 1.5 liter per day production occurs, but this depends amount of water consumption which is done by your body. So depending on that, there can be a slightest of variation. So 5 to 8 pH and ammonia like smell, that is due to bacterial activity. So these are the physical properties associated with the urine. Okay, then what exactly is micturition or urination? So it is the act of passing urine, so that we call a micturition. So under the impulse from the brain, so there is a relaxing of sphincter muscle which will be done. So once the sphincter muscle relax, there is a micturition or urination which is gonna occur. Okay, so then constituents of this urine, so this is urea, then creatinine, uric acid and others. So inorganic, when we mention, so sodium chloride, potassium chloride, ammonia and others. So all these contents you can find, so that is both organic as well as inorganic materials can be seen. So urea will have like up to 0.2, 0.3, the creatinine up to like 1.5. So depending on the type of diet that you have consumed, so again there can be slight of variation which you can find, but yes, so the urine formation will have the organic as well as inorganic one. Okay, and other than that, so there is a regulation. Okay, so how exactly regulation of this urine output is done? So there is a particular hormone which is called as anti-diuretic hormone, which is also a vasopressin. Okay, so this vasopressin hormone is released by whom? Anybody has any idea on this? Okay, so this hormone, the vasopressin, is released by which gland? Yes, any of you? What gland releases this ADH or vasopressin hormone? No idea? So this one is anyway a pituitary gland. And what pituitary? So it is the posterior pituitary. Okay, so posterior pituitary is the one which is releasing the hormone ADH or the vasopressin, which is responsible for reabsorption process. Like water gets reabsorbed. That is once there is the filtration of blood is done. No, so there is lot of required things like water, glucose, some of these salts. So those are required. Okay, so that reabsorption of water is basically done. That is mainly because of the hormone ADH, that is anti-diuretic hormone. So if this hormone is produced less or if it is not present, so then there is a frequent urination. Okay, so frequent urination, what exactly is the cause? So since the reabsorption of water is not occurring, all the water is going out as a urine itself. So in that case, you can find there is a frequent urination. Okay, which will be basically a dilute like urine. Okay, so this is a frequent urination can be found. And other than that, like this condition is basically brought about by lot of beverages. Okay, or the ADH, where the ADH secretion is going to reduce, so those are called diuretics, and this condition is diuresis. And this particular disease we call a water diabetes or diabetic insipidus. Okay, so this is water diabetes, or which can also be called a diabetic or diabetes insipidus. Okay, so insipidus diabetes is nothing but frequent urination can be found in certain people where the vasopressin hormone is secreted very less, or we can also mention it as absent. So that is when there is a frequent urination which will be done. So that is a water diabetes or diabetes insipidus. So this question is asked lot of times in your exam. So like give a reason question they can ask, or maybe what is diuresis and diuretics they can ask. So you can just check on this. Okay, alright, so this is control the concentration of urine. And other than that, so abnormal constituents, so there are blood cells. Certain cases there are blood cells which are found in the blood in the urine. So that can be because of UTI and other reasons. Okay, So there might be urinary tract infection. So there are certain cases where the albumin protein which is found in the plasma, so that albumin can be found in the urine as well. So the bile production, like too many RBCs are being dead, like the hemoglobin breakdown will occur. So that is when the bile production occurs. So this one glucose is with respect to insulin, like insufficient or hyposecretion of insulin is done. Okay, so when hyposecretion of insulin is done, so basically the blood will have much more glucose. Okay, so what exactly this insulin does? So insulin is actually responsible for regulating the amount, or we can say regulating the glucose level in the blood. So what exactly happens? So glucose will be converted into glycogen whenever there is too much of glucose in blood under the influence of hormone insulin, and this glycogen gets stored in the liver. Okay, so now since there might be associated condition where insulin production might not be there, so the urine will have a maximum amount of glucose present there. Okay, and artificial kidney, so this is basically a dialysis machine, and it is the one which is purifying the blood. Okay, so blood purification you can find, so that is mainly with respect to weekly twice. This dialysis has to be done for 12 hours, 9 to 12 hours. So that is basically complete filtration of your blood will be done. So since the kidneys are not working anymore, the complete filtration of blood has to occur. So twice a week this dialysis is suggested, where it is connected to the arms, that is through one of the vein. Okay, so blood supply is done and the purification. So the pure blood after this urea removal is done, so that is returned back to the body itself. So here the water balance in human body. So the adult human body contains nearly 40 liters of water. So there you can find 40 liters of water, which forms 60% of the body weight. So average daily loss and gain of water in adult human male, so that is in good health at rest, is so this is going to be conditions, like what all concentration you can find is mentioned. One second, let me just check this. I hope now it is clear, the video. I think I was moving on the other side. Okay, so now with respect to the contents, so loss, this is basically urine by kidneys, so it is 1500 ml. In sweat it is about 500, in breath it is about 400 ml, and other than in fecal material about 100 ml. So the total of 2500. So gain, if we have to mention, we drink, so let's say 1.5 liters of water. Okay, or in case of beverages only, so the food is basically having about 700, and the metabolic water, what is there? So that is product of cell respiration, so that is about 300. So in overall it is again 2500. So the intake and output of water would slightly vary according to the climate and the lifestyle of a person. So there can be variation associated with intake of water. So depending on the intake of water, so there is a loss of water. So summer we drink lot of water as in comparison to the winter, because summer what is happening, we feel thirsty. That is mainly because we are perspirating, there is sweating. So there is too much sweating where your body is trying to cool down your hotter body. So that is because the outside temperature is hotter. Okay, so in that your body will try to cool down your body. So that's the reason. So we feel thirsty and we drink lot of water. So that is during the summer. But in case of winter, so since already the outside temperature is cold, so there is no much sweat production occurring as such. Okay, so unless you have done a workout, like hyperactivity is done, so there can be sweating, or otherwise usually there wouldn't be any kind of sweating usually with respect to winter season. So in winter very less water consumption occurs, but in summer there is more water consumption which will be done. Okay, So this is about the artificial kidney, and any doubt till this part? So the first part one which I covered, so let's have a look at this. So you can see the excretory system. So we covered the excretory organ, the excretion, what exactly is artificial kidney, the constituents of this urine, the physical properties, regulation was done, abnormal constituents of the urine was done. So then other than that, the part of this nephron, okay, so that was discussed, and other than that, what exactly are the parts associated with the nephron? So that is structure of nephron, kidney was seen, and the associated organs were seen. So last minute preparation if you are going through. So you have already studied this chapter, but you just want to revise once. You can have a quick look at the mind map of excretory system, so that it will just help you in revising whatever you have left out. I hope this was useful. Okay, all right. So the today's session is done. So next I'll come up with the mind map session on nervous system. Okay, so you all can watch it. So thank you all. So see you all in the next session. So click on bell icon to get notified about the session. You can also subscribe to our channel, that is Unacademy, ICSE and ISC both. So like and share the video, and this PDF if you need, you can just search Vani Kari ICSE Class 9 and 10 Biology on Telegram. So once you find it, you can join there and you can ping me there so that I can send this PDF over there. Alright. So see you all in the next session then. Bye bye everyone. So chat section remains closed. Where? Here it is anyway open. You are able to type, no? So any doubts you have, you can anyway ask. So in Telegram you are asking, Bharg. On YouTube you are able to chat, no? So this is not closed, it is open only. So whatever doubts you have, you can anyway ask. It is anyway open. Okay. Alright then, so I'll end this session. So see you all in the next session. So that is day after tomorrow. Okay. So bye bye everyone. Take care. Thank you all. So the code is one second. So the code is Vani YT. I'll just write it here. Okay. So if you are planning on taking the subscription, so since we have come up with the crash course which has started from 17th of November. So if you are planning on taking a crash course, you can just use the code Vani YT to get 10% discount on your subscription. Okay. Yes. Okay. Alright. So see you all in the next session. Bye bye.